Kia ora koutou. This is question 2E from this year's Level 3 integration exam. Sorry if there's background noise. I'm making this at school at lunchtime, so you might hear some interesting Year 9 and 10 noises around me. Okay, so we've got the mass of a spherical object with radius p, and we're given an integral that we can use to approximate that mass. And this is the integral here. Now, it looks awful, but there are a lot of constants in here. So p is a constant, a is a constant, and b is a constant. And once you take account of that, then I think this question is not too bad if you are fluent with your achieved level 3 integration skills and doing backwards chain rule. So let's just start by writing it out and simplifying it a little bit. We can pull the 4 pi a through to the front of the integral, right, because they are constants. So that leaves me with 4 pi, and then I have r squared over 1 plus br cubed dr. Now, once you write it like that, you can see that you have got a 1 plus br cubed in the denominator, and you've got like a close relative of the derivative in the numerator. So looking at 1 plus br cubed, if we had y was equal to 1 plus br cubed, then dy by dr would be 3br squared. So we haven't got 3br squared, but we have got r squared. So that tells me that integrating this is actually pretty easy. It's going to be 4 pi a, and then I'm going to leave a gap for my coefficient, and it's going to be the natural log of 1 plus br cubed. And I have to do an adjustment here because when I differentiate this, I will get 3br squared. I just want to have r squared, so I'm going to divide out the 3b. And if you're working up at excellence level, you will have done tons and tons of questions like that. The only other thing to note is that I haven't bothered with the absolute value signs because we know here that the radius of a spherical object has to be positive, and b is told to us to be positive. So we don't need them because 1 plus a positive number is a positive number. So that's cool, right? So now we've got 4 pi a on 3b. And then we have to evaluate this integral. So remember, we're substituting in here for r. B is a constant. So working that through gives me 4 pi a on 3b times the natural log of 1 plus bp cubed minus the natural log of 1 plus b times 0. And the log of 1 is 0. So we get a final expression for m, which is 4 pi a on 3b times the natural log of 1 plus bp cubed. All right, so hopefully you liked that question. I think it's a really nice question. I think it's pretty accessible for an excellence level integration problem as well. So I'm going to do the Newton's law of cooling one soon, which is definitely the longest and muckiest one in the paper.